Yay. Hi, and welcome. As said, I am engineer, but I try to look not only on engineer's perspective of stuff, so that's why I'm here. And the topic today, monoliths, as everybody's talking about for 20 years. And no, I don't have the silver bullet that you were waiting for, because everybody would have found them somewhere in 20 years. Yeah, true, we still have to set up the screen. So far, there's only an intro slide, that's fine. But thanks for the reminder. OK, but this part is working, fine, cool. So let's go for the agenda. What do I want to do today? I always start with definitions. So we start there. And then I would like to go for what's actually the problem. Not so much the technical, but the other one. And what is a different view on the problem. And how to approach it, in case you got to convince people. Yeah, and the last point is I bring an example. So it is a standard agenda, but an interesting topic. Let's go. Let's start, as I said, with definition. I always start with definition. What's a monolith? And I found a definition that's super cool, because Martin Fowler is a perfect person to quote. And the definition is a monolith is a single logical executable. Cool. Because going by this definition, actually we don't have so much to do here. Second part is any changes to the system involve building and deploying a new version of the application. OK, I now got a definition of what is a logical executable. And I have the feeling that actually we can stop talking here. Because if this is a monolith and you split a monolith, you have two monoliths. So you cannot really kill it anyways. The only way to kill it would be to reduce a business case. Like, if you don't have the business case anymore, you can kill that stuff. So talk ends by this definition. Obviously, no. So next definition of what else can we do. This one, once again, Martin Fowler. Term monolith has been in use by the Unix community for some time. It appears in the art of Unix programming to describe systems that get too big. OK, this is something we probably can work with, because it's not about executables. This one is about size. And now we have too big as a term. So what can we do? We can do a graph of size. And this is not a formal graph, obviously, but it is something that happens in my mind. So we have the size of the executable. That's obviously something that can be too big. And we have the number of problems. Because if we don't have problems, we don't need to talk here. And what I did is I invented my sweet spot, the island I want to go to. That's somewhere in the middle. There's an area, there is some size where you don't have so many problems. That's where we want to go. And yeah, there are three problems why I put the graph on the right side. That goes up with a number of problems. And there are two that I put why on the left side there's also problems. So this is not a talk only about, hey, you have a lot of problems with monoliths. Avoid it, but also you have a lot of problems if you have two small services. No, there is no scale on that graph, because that's impossible to do, obviously, unfortunately. Otherwise, it would be easy. So let's go with the sharks. Let's stay with the islands. I have 3 sharks for today. And the first one is ownership. Oh, yeah, or whatever. Usually, if you have a huge application, you're talking about ownership of code. So technically, yes, you can have proper ownership in a huge application, but it's super hard. Often enough, you start to have code that isn't owned by anybody, because it's somehow, somewhere in the big application. It's easier with smaller applications, where you can put that team, this part, and so on. Then if you have a huge application, it's harder to understand what's in. So enough of times, people don't want to own that complex part. So it's harder to find owners. Yeah. Wait. Yeah, I forgot my animation, sorry. But now let's go for the build and deploy time, next part. So why do I see this as a problem too? If you have a huge application, build time, yeah, trivial. It takes longer to build a big application. Deploy time, the same. You can have the trivial part. It usually takes longer to deploy. Okay, that's the trivial stuff. I don't need to tell. The more interesting for me, it's also harder to work in a test-driven fashion and in small iterations if you have a huge application. That takes forever to deploy. So there's more in the build and deploy time than the trivial part. And last of the three sharks, scalability. That's the one a lot of pure IT view people see as the most relevant ones. Why? That was, I believe, the first one where people told the monolith is a problem. Like, you cannot just scale a part of the monolith. If you have a scalability problem, you have to put the whole service multiple times into your on-premise cloud or whatever. I believe back that day is more on-premise. But yeah, scalability was the first argument, and it's still true. If you have one small part in that application that has a scalability problem, you have to scale it all. And obviously, that's expensive. So now we're getting more in the direction of business. It's money. What oftentimes happens instead of scaling, it's money. So you get told, don't spend money. So people optimize code instead, because that's money spent once instead of money spent every month. And at least from my perception, there's a tendency to over-optimize, not to optimize. So you spend hours and months, even months, to optimize a small part that has a scalability problem and create complexity. Fair. Okay, enough with those three sharks, but remember them, we need them in a few minutes. I bring them back. Now, as I promised, the other side, because there's not only problems with too big applications, and we are not 20 years back, we are at the point of today. We know that nano services are also not the solution to everything, or serverless functions, or however you want to call those super small things that live on the left side. So there are at least two problems that you get on the left side. And first one, fast computation. What do I mean? Doing method calls and computation in one service is faster than doing network calls between multiple. That is not so much an issue if you have like 3 services talking, but if you start doing it serverless with 200, that is getting an issue at some point. Network is slower than just calculating in one service. Next, independence of change. This is usually something everybody wants. So you want to be able to do your one change for one feature in one service. It's cool, because then it's independent, you can deploy it, whatever. It's also fine if you have a small thing in a huge application, it's still in one. But if you have it split into like 10 or 15, you have to orchestrate how to deploy features. So actually, you're not on a point where one change is in one artifact anymore, but you're getting into trouble here. So far. So I hope by this non-mathematical graph, you agree that the sweet spot is in the middle. We know that on the right side, there are huge problems. On the left side, there are probably a bit smaller problems, but also problems, so the sweet spot is somewhere in the middle. I would summarize as we know the goal, but how to convince the crew. That was the title of the talk. I would also add when to convince the crew, not only how to, but it's also about when to. Because if your arguments are not good enough, maybe the reason is your problem is not big enough. So this is a moment of exactly that. So far, we talked about technical problems. And now the business question to that is, why should I invest money in this request for change. Like, you want to split a monolith, you want to spend half a year. Why? Why should I invest half a year, 1, 2, 3 teams into that stuff? Usually business want to reach goals, short-term goals more than long-term goals, so now the argument part has to come. Yeah, my personal answer to that is this book. And let's start with a quote, because I believe it describes the thing well. It is, we found that where code deployments are most painful, you will find the poorest software delivery performance, organizational performance, and culture. That sits well with me. So, a bit more. Accelerate is a book. It is more or less a founding book for the DORA metrics. It is written by Nicole Forsgren, Jess Humble, Gene Kim. It is not that unknown. What is a message in the book? It's quite well described in that quote. What is the important part here? There are metrics about operating systems, basically DevOps metrics. I take them in a minute. And they did research, like a lot of research, and you find it all in the book, that there is a correlation between those operation metrics being bad and your business also not running well. It is not causation. They have no proof that one thing causes the other, but you have correlation by bigger studies. So that's relevant. You probably all know the difference, correlation and causation. And so no need to explain that. But yeah, given this, there is a relation, so let's go for the metrics that they have. Here we go, sorry. Those 4 metrics are the original DORA metrics. They changed that over time, so I believe in 2023 it's not exactly those 4 anymore, there's something new, but this is the original one. So, first one, deployment frequency, you can read it. How often do you successfully release to production? And to give a relation, they talk about bad companies releasing like every half a year. This is still in business if you don't talk about modern German e-commerce, but more about old school, half a year is still running business. But good companies and deployment frequency, that's more every half an hour, something goes to production. And everything between is actually possible. Next one, lead time for change. So how long does it take a commit to get into production? There's a lot in, like from a commit to a merge request. Do you still do merge requests, or do you commit to a trunk? Don't know. What about your test suite? Given that your stuff is in main and fine, how often do you deploy it? Do you immediately deploy? Is there auto deployment? Does it go to any staging system or really to production? And so on and so forth. So there's more in it. So the real lead time is a thing. Next one, change failure rate. Like, how often do your deployments cause a failure? It's actually super important to have that metric, because otherwise it would be so easy to optimize for the first 2. Deploy everything every 2 minutes and you're done. Without the third one, you screw it up too easy. So this one is about how often do you have bugs and whatever. Problem here, obviously, what's a failure? What's your definition of failure? They also have that problem in the book. How do you define a failure? Is a small layout issue a failure or only a system breakdown? But on any definition, as long as you improve on your definition and your measurement, it's fine. And the last is time to restore a service. Yeah, I said it's DevOps metrics, so this one is important. Given that you fucked it up, how long does it take you to get it live again? You need that one. And surprisingly often, this one is ignored, actually. So it's the one thing is I found a bug in the code, and how long does it take me to get the fix live? The other one is I screwed up my server. Do I actually have all the images and everything? Is it proper GitOps so I can run it again, or do I get into real trouble here? That's also all in this matrix. Okay. 1 second, please. So I've now set it all up, like we have problems with our monolith, and we have DORA metrics, and what do I want to do next? Combine those two parts. So I will go through all 4 metrics and see where I see relations to our problems with our sharks. Those are actually things that I found in companies as real problems and how they relate. My hope is that you find 1 or 2 and can do the same correlation and maybe use that as an argument. So think about your cases while listening. Maybe that helps. First one, I was with deployment frequency. So how often do you deploy changes to production? And yeah, let's relate that with the build and deploy time of your application, because that looks like the trivial one. Given that your application takes forever to build, like forever, let me say it takes 4 hours to build the whole thing, including all images, it will be hard to have a deployment frequency less than 4 hours. Not impossible, but hard. This one was a trivial one. The one that I would be more interested in is, if it takes you long to deploy stuff, it is not just clicking a button, but also somehow being in that process. So it takes time and effort to maintain it. Like, think about, when do I deploy? Oh, it's 5 in the evening. I don't start that process anymore because I couldn't watch it in the night, whatever. What usually happens is people avoid to deploy. What happens? You build bigger batches of changes. What happens? Other metrics break. So the deployment frequency goes down if your deploy time goes too far up. Next thing, also avoidance. I said you bundle changes to deploy them. Most times, if you have really big monolithic application, you also schedule your deployments at some point in time to avoid that stuff. So you don't have to talk to who wants to change what when. You start with stuff like, OK, every day in the morning, and you have to put it into the trunk the day before till 12 or whatever. I believe that's a normal way how to do that without having too much overhead. But if you are there, it will be hard to have a deployment frequency more than once a day. Next, metric. Lead time for change. You remember? Time from commit to production. We start with the same again, with build and deploy time. Trivial answer. If it takes longer to build, your build is part of this process. It will take you longer. Yeah, OK, cool. The more interesting one, I just said bundle deployment, schedule deployment, whatever. So there's coordination in between. So this one goes up even more, even if you have a critical bug. Less obvious, so for me more interesting, is the correlation to ownership. Because why do I see ownership relation here? If you don't feel like the owner of your code, because you are just a part in a big application, you don't have the autonomy to change anything about your release process or your way, how to do CI/CD, if you do CD at all. You're just stuck, and usually you don't even want to change that, because most people just accept it at that point. So you cannot optimize it. You don't want to, and you cannot. So missing ownership also doesn't really help with a lead time for a change. Next metric. The change failure rate. So how often do your commits lead to fail in production? It's always the first one, the build and deploy time. I was with bundled deployments and scheduled deployments if you are there. So if it's just long, but you still do it at independent deployments, this is not a valid argument, but if you start bundling your deployments, then actually the risk is going up. Because you have no idea what you combine there, and given that you combine it, there's a risk of merge problems and whatever. So here we go. The failure rate will go up at that moment. And also, come on. OK, ownership doesn't have a red border. I'm sorry. Why ownership? This time not so much about code ownership, more about business ownership. Like, if a team really owns a service or a domain, usually you know what you're doing, and you know your edge cases, and you know what's going on. If you're just a small part in a monolithic application, usually you have no idea about what's going on somewhere else, far outside. So with missing ownership, you often enough have missing business knowledge about the edge cases. And now you see where I'm going. Missing knowledge about edge cases. That sounds like a good chance for more bugs. Here you have it. By the way, I forgot one for the build time, something that I just saw in my notes. A lot of times, if you have a long build time, not so much deploy time, that means that doing test-driven development is hard. Because if that thing takes long to build and you don't have a very good setup on your machine, you don't want to work test-driven in a way of I just run the tests and see what's red, because that would mean I run the tests, I grab a coffee, I wait 10 minutes, I see what's red, and nobody's working like that. So actually, really test-driven development is hard if your build time is too high. Not impossible. So you can do that. Stuff from whatever, proper jest setup, or also there's ways to solve that, but most of the times it's not solved, not good enough, because in small applications it's more like 5 seconds. So less test-driven. I now tend to say less test-driven leads to less or worse coverage of your application. That means less in percentage of code, but usually to worse in quality. So there is a higher chance of doing mistakes. Because most people just write a few tests afterwards to prove that they wrote tests. And that's not the quality of tests that you really want. OK. It might get tiring, but this is the last metric with the last correlations. And the last time with a build and deploy time shark. This time to restore a service means, given that you fucked it up, how long does it take you to recover? What is the build and deploy time in? Once again, the trivial answer, it will take longer to build the fixed code and to deploy it, obviously. This is a case where like scheduled deployments don't make any difference because you will do emergency deployments, but if it takes 4 hours to build that thing, it will still take you 4 hours to fix that. So it takes longer. Scalability. You probably can imagine what I want to say here. If that thing is huge, it usually takes longer to start and to set it up in production. This is no difference if it takes 2 minutes longer. But I mean, the monolith I was been working on 3 years ago, there's more, yeah, from deploying it to being ready in production, that's 1 hour of warm-up. Also with a fucked up system, we cannot make it faster. That's where I brought this from. It's better to have microservices where it takes you no warm-up at all, or maybe a minute, or maybe 2, but not this size. So, last one, ownership, this time with a red border. I only screwed it up once. Why? It's once again business ownership, what I mean here, not so much code ownership. If you feel like the owner of your code, usually you tend to have better monitoring of what's going on. If you have a small thing in a monolithic application, that's even hard to monitor what's going on. But if you have it properly and you can monitor it properly, where am I directing to? You will find out faster that you have a problem. It will not help you to recover from it faster, but you will find it faster. And in this time to restore a service, there's also the time between we screwed it up and we noticed that we screwed it up. Should be 0, but often enough it's not. Okay, that was a lot. Back to my island. So we have a goal somewhere on this graph, you remember. We have some arguments to convince the crew. Hope they might help. If they don't, maybe your problem is not big enough, or your argumentation, don't know. So the answer ideally is, yeah, okay, we get the goal. It's important. It solves some issues that we really have. But that's fucking expensive to do, still. So my last part is how to cut it small, given that you convince people to do something about your problem with your monolithic application. And that will not be so much detail because most people know. One more, and the last reference to Martin Fowler and the Strangler Fig pattern. So most important reason to consider a Strangler Fig application over a cutout rewrite is reduced risk. A Strangler Fig can give value steadily, and the frequent releases allow you to monitor its progress more carefully. There's risk reduction in it. That was great. Sounds like business argument. There is frequently, so we can have it in small parts. And you can monitor it. Also great. We were about business arguments. So what is Strangler Fig? Probably most know, but in case somebody doesn't, it means take out a small part, over time make it a bit bigger, make it a bit bigger, and at some point, the old application is just pointing to the new one, and then it's dead. And you can remove it. Why is it cool? Not only because of this reduced risk, but also because you can stop the process at some point in time. There are a lot of points where you can stop it, and the intermediate result makes sense. If you do a big rewrite and stop after 3 months, usually your intermediate result doesn't make any sense, and you can throw it away. Next good thing, you don't have to have the whole picture if you go like that. You need to have a good starting point where your arguments fit best, and then you can see where you're going over time. So one example I wanted to bring, and for that I finally have to talk about where I'm working. So don't know if anybody can read that. Unfortunately, it's in the back of the hoodie because Mr. Specs is an optician, and you always have this optician wording. Nice as a hoodie, but not so nice on a stage. So what are we doing? We're doing e-commerce, mostly. We also have stores, but mostly e-commerce. That's enough about the company. As an e-commerce, you have a web shop, monolithic application. That was great as a startup. And now the company is too big, and now we have to start separating stuff. Usual story. So far, so good. How did we do it? You have this example of a few domains in your application. And what did we say? We split out one front end. Because that is a nice fig to cut out. Why? It brings value immediately. One of our biggest problems was the page speed. So if you cut out the front end, you get better page speed already without changing everything else. Another big problem were actually the DORA metrics. In this case, it took us way too long to do changes, like A/B tests on the front end. Every story took weeks. And if we found out we have a problem, it took days again to take the test down. So this was another argument why the front end needs to get out of the monolith. Yep. We said we only do one part of the front end. Here I call it product browsing, like show a detail page, show a listing page, because now, then it has a size where you can start. Yeah. And now the next step is the fig grew a bit. So what we did is replace the previously internal search, means the backend for those pages, by an external one. Next part, moving over to the fig, and the monolith is a bit strangled. That's exactly one example how you can do it, given that you have people convinced that you have a problem, given, yes, our DORA metric case of our lead time for this part is really too long. So we started here to cut it out. Honest part also, those arguments were not valid for everything that is still in the monolith. So yeah, we have a starting point. Yes, this domain is separated. Nice, it lives on the right side. But the arguments are not strong enough for everything on the left side. Some other stuff has moved out, fine, nice domains, and some leftovers are in. So no, we're not done. As most companies, it's still alive. But fine. And that's why I bring the last quote. It's once again from Accelerate. And this is, you can read it as a motivational quote. So the most important characteristic of high-performing teams is that they are never satisfied. They always strive to get better. Why do I bring it? You want to move, you want to iterate on a part, fine. But getting better is not, I need to do the big rewrite, but more getting better is having a good look at what exactly your part is and what your problem is, and if your problem is really big enough, and what's the best solution for the problem. So, coming to my personal conclusion here, I named the talk like the monolith must die. I explained in the beginning that I can't do it on the definition. Actually, I'm also not convinced that you always want to kill it. 2023, we know nowadays, no, you don't want to kill all of them. Some monoliths are totally fair. And for some of them, the best answer is find good arguments to cut out parts that need to get out. But you don't have to completely kill it. And why did I bring all those arguments? Because IT people tend, not everybody, to be on a very technical side and say, this feels bad, I want to have it better. And then they say, the business managers, don't let us. So it always sounds like us having a problem versus them not allowing us to do stuff. And with those arguments, no, you actually have kind of shared goals. You have to talk about them and why they are shared, but then you can discuss the best solution together. What short-term and what long-term, and where in the middle is your sweet spot. Or more phrasing, usually business doesn't see those sharks. You have to show them, and then you can navigate together. Thanks.
Wonderful, thank you so much. We do have some questions already, but I hope more are coming. Are monoliths haunted by the stigma of legacy systems, or are they genuinely bad and to be avoided?
I don't think they are bad at all. Even broader as the answer. They are fair. Given you have a problem that can be easily solved in it, or your company is still small and you have a startup, so not bad at all. But this is was more about the case of when it's too big, and yeah, obviously this somehow matches most of the time your legacy code problem. Fair? Those arguments are more about this. Is it bad by DevOps performance? So then it's not about the legacy code because they don't really relate to each other. If you go for legacy, the longer I think about, yes, in one case it matches, and that was about knowledge about what's in. There, the legacy part plays a part in it. Because usually one problem with legacy code is nobody knows what's going on.
Brilliant. How do you monitor your DORA metrics to see progress?
Unfortunately, Felix is not here. There's one friend of mine who does a startup to try to do that properly. Depends. We do it by monitoring our CI/CD, in that case GitLab, via Datadog, and you can actually monitor a lot of them. Because if you have all your failures defined as incidents, you see what's going on and you can have resolve time there. Stuff like from commit to production, you can also measure that. So yes, somewhere in your CI/CD plus your production monitoring, you can sum it up. The big risk, and I really want to tell about that, is don't compare between numbers blindly. That one team has a lead time of 1 day and the other has 2 days doesn't mean that 2 days per definition is a problem. There's a problem if one team has usually 1 day and then surprisingly it goes up to 1 week. Then it would be fair to ask what's going on. But having different teams with different numbers, that's not a problem per se.
Just like the good old comparing of velocity measured in story points across different teams.
Yes, exactly. You can do exactly the same mistake here.
Is there also a general approach to link DORA metrics to business metrics? I'm the wrong person to answer. So I hope people are trying to do that. There's a whole group at this DORA group at Google, but I haven't read about good results. Fair enough. My management sees DORA metrics as too high level to be useful. Have you encountered that situation? How would you approach that?
I haven't, first of all. So I did not have that. I have the opposite. So I would need to think about for a second how I could do that. Actually, probably the person in the room, I would have questions back before answering it, because I would like to ask about why is it high level and what exactly is going on before trying to answer and find arguments.
That's fair enough. We can take it offline. Do you have any advice for dealing with shared ownership in inherently monolithic systems, like desktop applications, single-page apps, or mobile app clients?
I don't like shared ownership. That's my personal perspective, because it's super hard to do it properly. It's not impossible, but it's very hard. People tend to go like in this like tragedy of the commons problem, actually, like if everybody is responsible, nobody feels responsible for it. So at some points you have to have it officially, but I haven't seen that case yet. It is not possible, even in a shared code base, to split it by parts, like by packages or whatever, to say you are responsible for that part of the single page app, rendering whatever, the content, and we put that into that folder and that specific CI pipeline, and that's your part. You might have some shared code in the middle where you still have the problem, but so far we were always able to find at least one team saying, okay, we do the middle part, and not everybody.
Fantastic.
But don't get me into a rant about monorepos, please.
No monorepos. One last question. In the meantime, please remember that the poll is open for 20 minutes to rate this talk. What if you work in a controlled or compliant environment and your SLA contract allow you only 1 deployment per week? How do you improve DORA metrics then?
Nice question. It will be hard to have a better lead time to production than once per week then, or the same. Obviously, the answer is you can't improve the metrics that rely on the deployment per week, but probably you can go for the other ones and try to improve the other parts.
Brilliant. That's,
sorry.
That's all we have before lunch. Remember to rate the talk. Anja Kunkel, thank you very much.
Thank you.